Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
So, hello everyone. Hello Ashkar. I see you have arrived quite early today. So, I just need a confirmation that I am properly audible and visible. And I would request all who are watching me right now to kindly do a +1 in the chat so that I could know your name. Okay, and I would request you all to kindly keep this session as interactive as possible. That would, because in this way it will become both enjoyable for me as well and for you as well. Okay. Hello Rishit, how are you? Hello Asghar. Hello Rishit. Yeah. Just like Ashgar and Rishit, I will request everyone to kindly. Voice is very low. Shujata, is that so? Is my voice very low? Waiting for this session since a week. Thank you, Ashgar. Okay, so let me share my screen then, and let us wait for 1 or 2 more minutes for other people to join. Is my voice proper now? Okay, so yeah, so yesterday we were studying about essential mathematics topic that are usually important for SG interviews. But today we will be studying about stacks and queues. Okay, so I've already prepared a few slides that would be helpful for today's session. Yeah, thank you, Rishit. Yeah. Meanwhile, let me give you a small introduction about this series presently. Presently we are running this series called Practice Session for SDE Interviews. So, this series will focus mostly upon interview topics and questions which are very frequently asked in interviews. And I will be going topic wise, and for every week I will be taking a few topics, and I will be discussing important concepts and questions related to those particular topics. We have already completed binary search and essential mathematics. Now we are proceeding with stacks and queues, and then we will move forward with the recursion and dynamic programming. Okay, this will last mostly up to 40 to 50 minutes at max. Okay, today's session will be a bit less because this is the third session of the week, and okay, so maybe 40 to 45 minutes for today's session. Okay, today I will be discussing a very frequently asked SG interview question on stacks and queues. In fact, if anyone is asking you a question on stacks and queues, there is a 90% chance that they will ask you this question only. Okay, because in stacks and queues you don't find a lot of questions which are of good logical thinking questions, and this is one of them. Okay, so this one I would request all of you all to kindly pay attention to that. Okay, I suppose my screen is properly visible to everyone out there. Before I proceed, let me give you a small introduction about myself. So my name is Gaurav Kumar Shaw. I am writing it on the screen. You can look me up on LinkedIn, and if you would like to connect with me, you are most certainly welcome. I am a third year student at IIT Kharagpur. Okay, and I am a mentor at Geeks for Geeks. Okay, And apart from that, I have been teaching and delivering content for quite some time, and I have gained quite a good amount of exposure and expertise in this regard. Okay, so I will definitely be able to help you all out. Apart from that, we also have a course called Complete Interview Preparation, the link of which is attached. It is pinned on the very first comments. So this particular course is already there in the GFG portal. And if you're preparing for your interviews, so you can definitely check this course out. It contains most of the interview questions, and it's extremely well crafted as well. So yeah. So how many of you are in your second year right now, and you will be appearing for your internship season in the next 6 months, after 6 months or so? Okay. Uh, Campus internship starts from the month of July and August. So if you're aiming for those internships, these sessions and that particular course are going to be very very helpful, because they will help you prepare yourself for your interviews in a very very short amount of time. Okay. So let us get back to our question then. Yeah. So today we will be studying about stacks. Okay. The name of the session is stacks and queues, but majorly we will be looking into stack. And in fact, the one concept that we will study today is min stack. Okay. So do you all know about min stack? If a question is asked to implement something called as min stack, will you be able to solve this question? In fact, it is such a popular question that if any company is asking you an interview on stack question, it is a 90% chance that they will ask you to implement min stack. Why? Because the concept is very concise, it is logical, and only you will be able to only explain this concept properly if you have actually understood the concept yourself very properly. Okay. Otherwise, just mugging up the solution, you will not be able to explain properly, or if the interviewer is asking question, you will not be able to answer them. So min stacks become one of the most favorite questions in interviews related to stack. We also have something called as rainwater trapping problem, or histogram problem. Okay, so these are also implemented using stacks. Okay, and apart from that, we also have parenthesis matching problem, and we also have LRU and LFU cache. Okay, so LRU and I will be doing the LRU cache ones with you all, and mostly I will be doing these two questions: histogram, finding the largest rectangle in a histogram, or the rainwater trapping problem. Both are similar, and LRU cache. Okay, and LFU is also asked. So today majorly we will be focusing on MinStack. In the next session, I will be discussing about rainwater trapping problem and histogram problem. And finally, in the last session, I will be discussing LRU cache and few other concepts which may be necessary. So this will cover stacks and queues together. Okay, so this was about, and there is also one more thing called DQ is also there, and there is also another famous problem about DQ. So we will probably discuss that in the third session, which will be somewhere around next week. Okay, so this will be the agenda for stacks and queues. I hope everyone is tagging along with me and listening to me. Okay, next session means next week on Monday, Tuesday. Okay, it's not possible to cover all the topics in one session. It will last only for 40 minutes, because longer sessions, I don't think everyone will stay here with me and listen to me for more than 1 hour or so. So we try to keep the session at an optimal amount of time, usually 50 minutes or an hour. Okay, so let's move to the concept that we are supposed to discuss today. So the question is, you have to implement MinStack. Does anyone know about MinStack, or are you hearing this for the very first time? The question is to implement MinStack. What is MinStack? MinStack is basically you have to design a class that will basically allow you to push, pop, and retrieve the minimum element in O of one time. Okay, so you have to design a stack or a special stack in which you can push in O of one time. You can also pop in O of one time, and in fact, if someone is asking you what is the minimum element in the stack, you can get that in O of one time. You have to do all these three operations in a constant time. So you have to design such a class, and it should contain the push function, it should contain the pop function, the top function, and the getmin function, and a constructor as well, which will initialize it with the initial value. So this is a proper interview question. So in interview, exactly this question will be asked to you. Okay, so how will you do this? I would recommend you all to kindly learn of this concept, very very important, because This is one of the most famous questions which are very frequently asked in interviews. Could we also discuss the implement a calculator problem? It is a problem based on user stacks. Okay, Rishit, I will keep that in mind, and we will discuss in the next session on Monday, coming Monday. Okay, implement a calculator. Okay, but I would recommend you all to kindly listen to this concept very well. Rishit, do you know about implementing min stack? So it is basically saying us that what do we know about stacks? Okay, so we know that stacks is a last in first out kind of data structure. So let's say you are pushing a number one in the stack, then two, then three, then four, and then five, and then finally, if you just call the function st.top, you will get the top element of the stack, that is five, and if you pop that element, you will get five out first. So whatever element which is coming out going inside last will come out first. So this is a stack. Now, you can easily do a push operation in O of 1. You just need to push it into the stack. You can also do a pop operation in O of 1. Okay. You can also get the top value of the stack in O of 1. But if someone is asking you to get the minimum value of the stack, minimum value present in the stack, it is not possible to do in O of 1. Just means it is actually possible. That is why the question exists. But there do not exist any function that you can give directly in O of 1. Okay, you have to design such a function. Okay, so there can be a brute force method that you can think of, is that let's say you fill your stacks, then you empty your stacks one by one, take out all the element, and once you're taking out all the element, keep a track of the minimum. Keep track of the minimum. So in this approach, the time complexity become linear, O of n. Okay, so this is not a good approach. Again, then if someone is asking you to push a new element, you have to again push back all the elements which you popped out initially. So this is actually a very bad kind of approach, and this will not help you get anywhere related to the question. Okay, so any ideas how we will do in constant time? Any idea? So we have 11 people with me right now. I would request all of you all to kindly do a +1 in the chat, and at the same time like this session or the stream on the YouTube. And apart from that, I would request you all to kindly check out the question. Uh, Kindly check out the link of the complete interview preparation, which is pinned on the very first comment. Okay. Should we use hash? I don't think these will not help you do it in constant time. You can use variations of hash map set, but it will not help you achieve constant time. Okay, so you can do something like this. Like for example, let's say you have a lot of elements in a. Let's say I give you an array which contains a lot of elements. Let's say 10 or 12 elements, and you push inside the stack one by one. And at the same time, once you're pushing it inside the stack, you are asking that you would like to keep those elements in a hash map or a set. Okay. The problem here is that I missed telling you this. The question also says that you have to use only one space. You are only allowed to use one stack only. That is, your space complexity should be linear. Okay, so only one stack, and you should not use any other data structure. Like you cannot use a set, you cannot use a map. So basically, this will defeat the purpose of the question. The question is asking you to design such a class which just by certain kind of operations, certain kind of logic, you will be able to get the minimum element in O of one time. Okay, so in fact, this question is actually a very special kind of question because uh, why is this a special kind of question? Because if you do not know the answer to this question, you will not be able to solve it. Okay, so you have to basically learn of the intuition of this question. Could we use another stack to keep track of the minimum? Yes, you can use that, but the space complexity will become 2n. You have to use one stack to store the element and the other stack to keep track of the minimum. So you're using in fact two stacks. That is also a valid solution, but you are asked to only use one stack for to solve this problem. So this is where the difficulty lies here. Those are the easier versions of the same question. Okay, so anybody would like to write a heap? Someone is saying heap. As I said, you are not allowed to use any other data structure. You are only allowed to use one stack. Okay, any other ideas? So you have to basically purely design the function with the help of logics of maths only. Okay, and not any data structures apparently. While filling the stack only, we can use min function. Yes, you can do the min function, but in that way, what will happen? I will show you one problem exists in that way. Okay. Okay, let's say you are filling 10 elements inside the stack, Azure. So now I ask you to, you keep track of the minimum also. So you will tell me the minimum. Now I ask you to pop the first three elements out of the stack. And then I am asking you to again give me the minimum. So in that case, what will happen? The minimum which you calculated initially is the minimum of the first 10 element. But again, the minimum of the, after popping out the element, you have lost that minimum. You do not have that minimum. So you will not be able to tell me that minimum. Okay. So the question is that you have to design such a function that at any moment of time, if you want a minimum, so it will give the minimum value which is present at that particular moment in the stack. Okay, and not anything else. What you're asking will give you a minimum in O of one time, but it will only work once, the very first time. After you start popping elements out, you have lost the minimum value. That is no longer valid. Okay. What it Ashkar, what is the incorrect idea behind your approach? Any more ideas? As I said, that either you know about this concept, and then it is very difficult to actually come up with an original solution just by thinking. So I would request you all to kindly learn of the intuition and produce the same when you are asked in an interview. Okay, so let's see. Yeah. So this is actually a nice solution in one way. What you can do basically, instead of storing one element inside the stack, you can store a pair. So you can declare a stack in this fashion. Of pair of two values. Okay, intent. So if you're being asked this question in an interview, the first approach you can tell is this. So this will actually solve the question which is being asked, but this is not a very optimal approach because you are putting two values inside the stack. So in fact, the space complexity becomes twice of n. So it will take twice more space than actually it would usually take. Okay, so the space complexity increases, but the time complexity is optimal. So in the next approach, I will be telling you in which the space complexity will also be only one stack O of n and not double. Okay. So in this, what you can do basically is that you take a pair of element, you insert an element, and at the same time you insert the minimum value up to that element. So let's say you insert minus 2 first. So the minimum value will be minus 2. Then you insert 0. But the minimum value will still be minus 2 because minus 2 is the minimum value till now. Then you insert minus 5. Now once you insert minus 5, the minimum value will change to minus 5. Okay. So there is a small correction in there. So once you are inserting minus 5, the first value is basically the value which you want to insert, and the second value is basically the minimum value till there. Okay, so minimum value till here is minus 2, minimum value till here is minus 2, minimum value till here is minus 5. Okay, so in this pair, the first is the value which you are pushing, and the second is the minimum up to that point. Okay, so this is the idea behind this approach. The time complexity will be O of 1 and the space complexity will be O of 2n because you are using a stack, but you are using one stack only, but you are putting two values. So whatever space the one stack with one value would take, this will take twice that space. So this is why this becomes suboptimal in nature. Okay, so there is a very good and logical optimization for the same problem. Store the gap between the min value and the current value. Okay, Utkarsh, yes, you are moving in the right direction. You have to store the difference between the min and the current value, but some kind of complicated mathematics is involved here. I will discuss there. It's not complicated actually. There's some kind of simple maths is involved that will actually help you get the same thing, but in O of one time and linear complexity of space. Okay, Yeah, so the students who have joined late, I would request you all to kindly do a +1 in the chat, and at the same time, you can also keep the interaction going on in the comments. And apart from that, you can also check out a course called Complete Interview Preparation, which is pinned with the very first comment, and that is actually a very good course, and it's extremely well crafted if you are aiming for preparing for your interviews. Okay, so let us look at this new operation that I just discussed. So let's say that you want to perform these three operations. You want to push -5, you want to push 1, and then in fact this is 0. Yeah, and then you want to push -7. Okay. After you push all these three value, I would then you have to also keep track of the minimum value at every point of time. Okay. So the what you are supposed to do? Let's say you have -5. So you declare a stack and you put -5 inside that stack. Okay. So I'm doing in the new slide. Okay. So let's say you declare a stack. Okay, this stack will only contain a integer variable. So the first element that you want to push is -5. So you put -5 inside the stack. Okay. Now what happens? The next element that you want to push is 0. Okay. Now you have to check. Okay. So there is one more thing that you have to do. You have to keep track of the minimum value till now. So initially, what you can do basically keep the minimum value as infinite. Okay, or int max. So the as soon as you get the very first element, and then you change the value of int max to -5. Okay. Now the next value that you want to push is 0. Now you will check whether the 0 is less than minimum or not. In fact, 0 is actually greater than -5. So addition of 0 to this stack will not change its minimum value. So what we will do? We will simply push the 0. Okay. So if an incoming element, I am writing in words, if an incoming element is greater than the minimum till now, what you will do? You will simply push that. You will simply push that inside stack. Is it clear till now? Can I have a +1 in the chat? Is it if it is clear? Hello, Alok. If it is clear till here, can you just do a +1 in the chat that you have understood it? That why the first condition that we are checking is that if the incoming element that we are supposed to push inside the stack is greater than the minimum value. Okay, so it means that that particular element is not going to affect the minimum value in any way. Okay, so we can simply push inside the stack. Is this part clear? Just do a +1 in the chat if it is clear to everyone. I want to proceed slowly and okay. Thank you, Ashkar. Thank you, Rishit. Thank you, Alok. Okay. So now let's see what is the next step. So this was the first step. Now let's say I want to insert -7 inside my stack. Now what is happening here? -7 is basically a number which is less than -5. It means that if I insert -7 inside my stack, my minimum should change to my minimum should be changed to -7. Okay. So let's say I am doing this. I am inserting changing -5 and I am putting -7 and I'm inserting -7 as well. Okay, now you have simply inserted -5, -0 and -7. Okay, so these were the few elements that you wanted to insert. Now I'm asking you that what is the minimum element till now? You can say that the minimum element till now is -7. Now I'm asking you to pop -7. I'm asking you to pop the top element, that is pop -7. So you remove -7 out of the stack. Now this is your stack. Now I'm asking you what is the minimum element of the all the element present inside the stack after you remove -7. Your minimum variable is containing the value -7, but actually the answer should be -5. So you are getting a wrong answer in this case. Okay. So it means that if you are getting a number which is lesser than the minimum element, which is a minimum value till now, you cannot just simply put inside the value, because in that way you will lose the minimum. You will get your minimum value will get lost. Okay. So has everyone understood the fallacy here? Why we cannot simply insert the element after we have got it to be less than the current minimum? Yes, exactly, Alok. So if someone is asking you to just push all the elements inside the stack and then tell me the minimum for all the elements inserted till there, you can easily tell. But once you start popping elements out, you are basically losing track of the minimum value calculated till now. Okay, I hope it is clear with this. So now let's move to the next part of the concept. So till now we are very clear that we are not allowed to insert the element directly if that particular element is lesser than the current minimum. Okay, so instead of inserting that element directly, what we will do, we will insert a modified value of that particular element. So listen to it very carefully. So if the incoming element is less than the current minimum, the minimum variable, we will insert the modified value. Okay, I hope everyone got it. So what is the modified value now? So let's say the value is represented by val. So the modified value will become 2 into val minus minimum. Okay, so the modified value is 2 into val minus the minimum. So this is a modified value that you would like to insert. What will be the value of this? 2 into val is minus 7, and minimum is equal to the minimum is minus 5 till now. Okay, okay, so let me just erase this part. So in fact, minimum till now is minus 5 after you have inserted two elements. Okay, okay, so let me just write minus 5 once again. Minimum is minus 5. So 2 into minus 7 will be minus 14, and minus of minus 5 will be minus 14 plus 5, which will be equal to minus 9. So instead of putting minus 7 inside the stack or pushing minus 7 inside the stack, you will push minus 9. Okay, so the concept here is that whenever you are getting an incoming element which is less than the current minimum, you will insert the modified element. Okay, I will discuss the intuition after I have explained the concept. Okay, so let me just write all the summary of the portion till now. So the summary will be, if the incoming element is less than the minimum, if it is greater than the minimum, in that case simply push that element. If it is greater than the minimum, you simply push the element into the stack. Minimum variable is not affected. Else, if the incoming element is less than the minimum value, in that case what you do, or you can just write greater than or equal to, use push the modified value. Modified value. Okay, so modified value will be 2 into value minus the minimum. Okay, this is the summary till now. I hope everyone understood it. Hello Nikaj, welcome. Um, yeah, today we are studying about MinStack, and the topic of discussion is stacks and queues for this session and for the next upcoming few sessions. Okay, so I hope you know about MinStack problem. Okay, so this is a modified value that we pushed. Now I hope everything is clear till here. Now once we have pushed the modified value, what are we supposed to do now? What we will do basically is that we will update the minimum value also. The minimum variable was minus 5 till the second element. Now as I inserted minus 9 into the stack, I am supposed to update minus 5 to minus 7 because minus 7 is a new value. Okay, so once I have inserted the three element, if someone is asking you what is the minimum value till now, you will just return the value of the minimum. It is minus 7. In fact, there is no such element as minus 7 inside your stack, but still you will report that the minimum value is minus 7. Why so? Because you entered a modified value of minus 7. So minus 9 is a modified value for minus 7. In fact, minus 9 is representing minus 7 only. So the minimum is minus 7. Now if someone is asking you that let's pop the top element out of the stack, that is you pop minus 9. So now what is the minimum element? So there is a rule, sir. There is one small rule here, that once you are popping an element, you have to do a check, and you have to do certain operations after that check to identify the minimum. Okay, so the basic step here is that the previous minimum was minus 5. So initially when we were simply pushing the element, we lost track of the previous minimum, but pushing the hmm, pushing the modified value is helping us to keep track of the previous minimum. Okay, so let me write this in the summary point. So summary point would be that keeping the modified value is keeping track of the previous minimum. Got it? So how is this maths working? I will explain it to you after around 10 minutes, because it will take 10 minutes for me to explain this entire concept, and then I will go back to explaining you the intuition. Okay. Now there is one more thing that you have to do. Now the question is asking you to pop the elements. So initially what was happening when we were popping the element from the top, our minimum was getting lost. But here we have a rule to how we will pop the element, because the question was asking you to pop -7, but in your stack you have inserted a modified value. So you are not supposed to pop out the modified value. Okay. There is a certain special reason that you have inserted the modified value. So therefore you have to do some operation before you pop out. So now the thing is that if the modified value which you are basically trying to pop out, if it is less than the minimum value. So initially we inserted -9 and the minimum value was -7. So -9 is less than -7. If it is less than -7, it means that it is a modified value actually. Okay. Why it is a modified value? Because if you have found an element which was less than the minimum, you inserted a modified element. Okay. So modified element was 2 into value minus minimum. Okay, so 2 into the particular value minus minimum. So if the modified value is less than minimum, it means that particular is a modified value. So what will happen? So the question is saying that change minimum only if the modified value is being popped. So if the modified value is being popped, you have to change the value of the minimum. And how you will change the value of the minimum? You will change the value of the minimum by this formula. You will do 2 into minimum minus modified value which you are popping. Okay. So what is the value of the minimum here? The value of the minimum was -7. So 2 into -7 minus the value that you're popping is -9. So 2 into -7 is -14 plus 9. -14 plus 9 is equal to -5. Okay. So the minimum value becomes -5 now. After you pop out -9. As you can see here, once you pop out -9, the minimum value will change to -5, because -5 was the previous value of the minimum. And just by updating the minimum value, we actually changed we actually rolled back the value of the minimum to its previous value. Hmm. So let us write a small summary once again. So this is basically the condition for popping. Okay. So condition for popping. So the condition says that if the value that you are value to be popped is less than minimum, it means that this is a modified value. And if it is a modified value, we will update the minimum. Update the minimum by the formula minimum is equal to 2 into the present value of minimum minus the modified value that you are popping. Okay. So this is basically the minimum value previously, or you can say previous main value. The minimum value which was supposed to be the minimum value when you had not inserted the modified element. Up till that position, this was the minimum value. So this, by doing this operation, you will obtain that particular minimum value. So the flow of approach is quite simple now. Okay. But if the value that you are trying to pop is not is greater than or equal to the minimum value, in that case you can simply pop out. Okay. Minimum won't get affected. So I have just written the same thing here. If the modified value is less than the minimum, uh, so yeah, the idea of updation is that if modified value is less than the minimum, so let's say that the modified value is less than the minimum. So what will happen here? Val minus min is less than 0. So you do a plus val here and plus val here. So 2 into val minus minimum is basically becoming less than val. Okay. So this is the modified value that we were trying to insert, and so this become lesser than the minimum value. That is the reason that modified value is actually lesser than the value. Hmm. Got it? So this was the intuition behind the maths, that why you are inserting a modified value in place of the actual value. Okay, Askar, you're asking that can you say again about the modified value? Yeah, I will once again repeat the same thing. I just could not see the comments. So the thing here was that let me give you a small. Listen to me very carefully. So I'm saying is that once you are getting an element which you want to push inside your stack, but that particular element is actually um, less than the current minimum. Okay. So what was happening here? I inserted -5, my minimum value is -5. I inserted 0, my minimum value is still -5. Now I want to insert -7. The minimum value is -5. So -7 will basically become the new minimum. So once I am seeing that -7 is actually less than the minimum, I will not update my minimum directly. What I will do, I will instead of pushing -7, I will push a modified value of the -7. Modified value of -7 will be 2 into the value minus the current minimum. So you instead of pushing -7, you will push 2 into -7 minus the current minimum into inside the stack, and then you will update the minimum value. Why we are pushing the modified value? Because you want to keep track of the previous minimum. The previous minimum was 5. So in this -9 contains two terms. The -9 is a -9 contains the value also, the -7 also, and -5 also. It contains both the value in itself by some operation. So the idea to insert a modified value is to remember the previous minimum somehow. By some mathematical operation, you can basically get the previous minimum. That is the concept of inserting modified value. Okay. Now, once you have inserted modified value, you want to pop that particular value. So whenever you are popping a modified value, and how will you identify whether a particular value is modified or not? If that particular value is less than the minimum, in that case, what will happen? It is a modified value. Why? Because your minimum variable is saying that the the minimum value till now is -7, and the top of the stack is saying that the my value is -9. So how is it possible? Value of inside a stack is lesser than the minimum. Okay, so if you're getting if you're standing at this situation, it means that -9 is not the actual value; it is a modified value. So once you are trying to pop out a modified value, what you will do? You will update the minimum also. The minimum will be, you will update by the formula 2 into minimum minus the value which you want to pop. That is the minus the modified value. Got it? What is the importance of the formula 2 into value minus min? In the sense, could it have been 5 into value minus min? I'm telling you why. Uh, so this is basically the intuition behind C. Why we are the idea to introduce the modified value is to keep track of the previous minimum. So let's look into some maths here. So here you see that you have got a value. If it is less than minimum, okay, at this point of time, what you can do here, let's say value minus minimum is less than 0. You add value to both sides of the equation. So 2 into value minus minimum is becoming less than this present value. So initially your value was -7 and this value was -9. So -9 become less than the actual value, right? So the minimum was supposed to be -7, but you got a new value which is lesser than the minimum. Okay. So that is the reason this is your modified value. Why is this a modified value? Because it will help me regain back the previous minimum. Okay. Now how is it happening here? See, uh, I am if I am trying to pop out a value which is lesser than the minimum, it means it is a modified value, right? So I am changing my minimum to this value. So 2 into minimum minus st dot top. So what is st dot top? St dot top is nothing but modified value. And what was the formula of modified value? The formula of modified value was 2 into value minus the previous mean, right? So 2 into value minus whatever minimum element it was, the previous minimum. Now, if you look at very carefully, the minimum value, the value of the variable minimum and this particular value are same. The minimum is -7 and this particular value was also -7. So in fact, this will get cancelled out and you will be left with previous minimum. So once you are popping out something which is a modified value, your minimum also got updated to its previous minimum. This is the entire crux of this concept. Okay. Initially, what was happening? Once you were popping out, there was a problem. You were losing the track of the minimum value after you pop out an element. So, but in this concept, it is not happening. If you are popping out, you are appropriately changing the value of the minimum by this formula. Okay. So this will never you will never lose out the value of minimum if it is changing. Rishit, did you understood it or should I repeat once again? Hello, Naikach. Hello, Ashkar. As I said, that this is an extremely important concept for understanding min stack, and this is a very very popular question. And if hello Pramod, how are you? I see that you have joined quite late. So we are doing this is a session for stacks and queues, and we have currently solved the question called implementing minimum stack, where you are required to implement push pop and define minimum inside a stack in constant time and linear space. Okay. So Rishi, did you understand that why we did not push 5 into value minus minimum? So see, if you would have put 5 into value minus minimum, what would have happened? Let's say 5 into minus 7 minus 35 minus of minus 9, so it would be definitely be less than the minimum. But again, you have to roll back the same minimum, right? So you have to, if you're using 5 into val, so make sure you're again using see, so if you would have used 5 into val in this question, so here would be 5 into val. Okay, so now here also you have to make sure that you're doing 5 into minimum minus 5 into val so as to get the same. Okay, so there is no concept like you can do 2 into val or 3 into val, it doesn't matter. The idea is to get the previous minimum by some mathematical operation. If you remember that we used to do a problem called swapping the two values of a and b without using a third variable. In that case, what we used to do, we used to write something like a is equal to a plus b, and then we just used to do some mathematical operations to store the to swap the value without taking a third variable. So this is exactly same trick. You are doing some kind of plus, minus, and multiplication to keep track of the element that you are currently considering. Got it? So is this concept clear to everyone? I would request everyone, once again, I'm requesting you all to kindly learn this concept because this is very important and it will be asked to you in your interview. Okay. So now let us look into the C++ code. So yeah, in the question it was asked that you have to implement a min stack. So first of all, you have to initialize a constructor, this min stack function. Inside that min stack, if your stack is empty, if your stack is not empty, you are basically allowed to pop the stack, and minimum will be int max. Okay. So now what is you have to first initialize a push function. So what is a push function? The push function takes a value. So val is equal to value. Now if stack is empty, it means that but if a stack is empty, it means that no problem. You just simply push that element and you update the minimum. The minimum will also be that element. So if the stack is empty, that is basically this val is the very first element. It is the very first element that you are trying to push. Now else part, if stack is not empty, now we have two conditions. If the stack is not empty, in that case you have to check whether the value is less than minimum or not. If the value is not less than minimum, that means if the value is greater than or equal to minimum, you will just simply push the value because minimum is not getting affected in this case. Minimum will still remain the minimum and it is not getting affected in this case. But if the value is less than the minimum, you have to update, you have to push the modified version of the value. You have to push 2 into value minus minimum and then update the minimum. Okay. Why you are pushing this value? Because once you will pop out this value, you can also roll back the previous minimum. Got it? So void pop. So now this is the pop function. Now if the function is empty, if the stack is empty, there is nothing to pop out. So just return. Now if this function is, if the stack is not empty, you take the top element from the stack and you pop the top element. Okay, this is st.pop. Now you check whether the top element of the stack is less than minimum or not. If it is less than minimum, this signifies that it is a modified value. If it is less than minimum, it means that it is a modified value. And if it is a modified value, then what you are supposed to do? You are supposed to do this operation. You are supposed to do minimum is equal to 2 into minimum minus element. Okay. So this means you are rolling back the previous value of the minimum. Got it? I hope this concept is now very clear to everyone. Pramod, we are basically discussing stacks and queues today. Today we discussed a very important question called min stacks. And in the next session onwards, we will be discussing about rainwater trapping problem and histogram mostly. Okay. Could you please show the top function once again? So where is top? Yeah, so this is the top function. So top function basically wanted to give you the top element. So what is happening here? in fact, you're taking the top element, and if that element is basically less than minimum, you will return the minimum element. Otherwise, you will return the element. Okay. Why you are doing this? See, it means that this function is asking you to return the top element. If that particular element is less than minimum, so that is a modified element, right? So you're not supposed to return a modified element, because modified element you have inserted for your own benefit. Okay. So what you will return? You will return the minimum element, because this is the value till that position. If it is not less than minimum, in that case you can simply return element, because that is the value, that is the actual value, real value. In this case, it was a modified value. So you return minimum. Now, if this is a function called getMin, in that case you will return a minimum. So all these functions are basically wrapped inside a class. Okay. So this is the exact implementation of min stack approach. I hope everyone understood it. Okay, this is the pop function, this is the push function, and this is the top function. Okay. So any more doubts here, or any more questions? So can you kindly do a +1 if you have properly understood this concept? I hope I was able to make it clear to you, all of you. Yeah, so once again, I would request you all to kindly check out the course called Complete Interview Preparation, the link of which is attached in the, it is in the very first comment. Okay. Hmm. So you can also try to solve this question on the GFG practice platform itself. Okay. Hello, Anand. Thank you very much. Hello, Rishit. Thank you very much. So yeah. So let us keep our session till here only. Okay, so next session we will be discussing another important question on stacks and queue, and it will be next week on Monday. Okay. Apart from that, there is something. So we are also having something called a live mock DSA on this very channel itself. So if you are preparing for your interviews and you would like to have your mock interview scheduled with any of us, any of the mentors at Geeks for Geeks, you can try to fill up that form, and we will try to schedule you. Okay, because preparing for mock interviews is kind of extremely important if you are if you are seriously preparing for your interviews, for your internships or placements. Okay, and yeah. So, do you guys have any questions, or should we wrap up today's session? So, yeah. Also, I would request all of you all who have joined late to kindly like the streaming on YouTube, the stream of this particular streaming, and at the same time subscribe to our channel as well, because we are planning to provide great quality content over the course of the next few months, and it will be certainly be very helpful to all of you all. Okay. So this is a link to the Jamboard session that I just used. Okay. So in case if you would like to refer to the things that I just wrote, you can check out the link. Okay. This was yeah. Apart from that, if you guys have any question, you can just shoot right in the chat box. I'm here for a couple more minutes. Is there any way we could access the board of the previous session? Previous session, I actually put it in the description. I remember. You can check out the description. I actually put the link there last session. For stacks and queues, this is the first session. Previously, we discussed about essential mathematics. We discussed about binary multiplication and binary exponentiation, and we also discussed prime number and sieve algorithm, as far as I remember. Okay. Okay, then let us wrap up our session till here. So, thank you very much for joining today's session, and a very good night to all of you. Let us meet at the next session then. Bye bye. Alok is asking a question. He's asking that 1, 2, 3, 5, 3, 1. Can we do a min stack on these elements? Yes, of course you can do. You will insert 1, then you will insert 2, the minimum will be 1. Then you insert 3, the minimum is still 1. Then you insert 5, the minimum is still 1. Then you insert 3, the minimum is still 1. Then again you insert 1, the minimum is still 1. So it is quite simple actually. You are not actually using modified value. You will only use modified value if your incoming element is less than the minimum value recorded till now. Okay. The only reason to use modified value is that you want to keep track of the previous minimum which you have, which you don't want to lose track of, because that previous minimum will help you in case you are popping out an element. Okay. Hello, is that clear? Okay, then see you in the next session. Bye bye.